Okay, so now we are going to be multiplying polynomials. This is kind of confusing, but stick with it. This is, like I said in my email, we're into the algebra now that's brand new, that you've not seen before. So it's going to be a little bit challenging. So just know I need you to ask questions if you need help, and we will work something out, okay? So this, as like I said in the other video, this is why a lot of kids now, whoops, I've got to edit, I'm sorry. I got out of the habit of having to record stuff. So this is why a lot of the kids now are learning to multiply like this, and it's kind of freaking some parents out because this is not how we learn to multiply. But if we have 32 times 17, for example, the way I learn to multiply is 7 times 2 is 14, carry the 1, 21, 22, 320, 4, so 544, okay? This is how some kids are learning it, and there's a reason why. We're breaking apart the 32 into 30 and 2, and then the 17 into 10 and 7. And just like when we found the area model, when we were distributing, we're kind of doing the same thing. So what's 30 times 10? Well, it's 300. 7 times 30 is 210. Yeah. 7 times 2 is 14. And that is 20. And then they're adding the parts together. So the sum of the whole. So I have 300, I have 210, I have 20, and I have 14. And we add. So we have 544. So the reason a lot of kids now are learning to do multiplication like that, it's to prepare them for what we're about to do today, where we're about to multiply using the area model, which to me is kind of the easiest way. I did not learn to do the area model until I started teaching algebra, but it makes so much sense now, okay? So to multiply x times x, just like when we distributed, I have x squared. I have x times -5, so that's -5x. 3 times x is 3x. 3 times -5 is -15. And so like it says up here, now we're going to collect or combine the like terms. And generally, my like terms will be on the diagonal from each other. So we have x squared, 3 minus 5 is -2x, and then we have -15, and you're done. Okay? Area model is going to be the simplest, and you will get really quick at it. Just give yourself time. So here, I'm going to put my 2x here, my 7, here's my 3x, and here's my -1. 3x times 2x is 6x squared. 3x times 7, 21x. -1 times 2, -2x. -1 times 7, -7. We're going to combine like terms. I always start with the 6x squared because remember they go in order of descending order of exponents. So, and then I combine these, I have 19x, and then I have my constant. Okay, that's how we multiply. They're not going to give you a grid. You're going to have to do the grid on your own, and that's why this activity was scaffolded. And it honestly doesn't matter what factor you put first. Okay, I'm going to go ahead and show you. I'm going to put this factor on the top, and I'm going to put this factor on the bottom. And now we're going to multiply. 3r squared times r, 3r to the third power, negative 27r squared, negative 2r, and 18. Now on this particular example, we have no like terms, so I write them in order of descending order of exponent. So 3r cubed will come first. Then I have negative 2r squared minus 2r, and we have plus 18. And so this is your final answer. Okay, and again, something you need to understand is that Desmos will not do this. The Inspire will not do this. Neither one of those, they're great, and together they're amazing. Separately, they're great. Together, they're amazing. Neither one of those tools will allow you to multiply polynomials. This is something you have to do on your own, just like this. Okay, so if you need to, screenshot this, copy this down, pause this. I need you to understand how to do this because this is really important. Okay? Okay, so we have two more methods, and to be perfectly honest, I do not like the distributing, but because it gets kind of messy, I think. But distributing, just like we distributed only one term to two.
10:27 a.m.
We distributed one term. When we distributed, here you're taking both of the first terms and you're distributing it by each term in the second term. So I have negative 4x squared minus 5x minus 24x minus 5, combining like terms, negative 4x squared minus 29x. Oops, that should be 30, plus 30. I missed that. Plus 30, you're done. Now, the FOIL method. This, I will tell you, this is how I learned it. Okay, this is the only method I remember learning. And we even called it FOIL. So it's the first, you're going to multiply your first two terms. So I'm going to multiply 2x times x. The O stands for your outer. So my outer terms are 2x, negative 7. The I stands for inner, which is 5 times x, and L stands for last, which is 5 times negative 7. And then, so that's 2x squared, negative 14x, 5x, negative 35. We still have to combine my like terms, so we're gonna do the OI generally are your like terms, so that's what you're gonna combine. So I have 2x squared minus 9x minus 35. So that is the three methods. I generally, when I am doing these, because I have to do the work just like you, when I'm doing these, the method I prefer is the area model, or you'll hear it called the box method. And I will caution you, you can only use FOIL when you are doing binomials. And remember, that is the two terms. This is only. So if you are doing a trinomial times a binomial, you cannot use FOIL, okay? So, 3 examples. You get to use the method of your choice and understand that this, I have a binomial times a trinomial, so I can do the distributive method, or I can do the area model or the box method. You cannot use FOIL. So for this one, if I wanted to distribute, it would get kind of messy. So this is why I really prefer the box method. 3 columns because I have a trinomial. Two columns, and then you're just multiplying. So you're only really multiplying, you're finding the area of each little rectangle, and then you're adding everything together. So x times x, x cubed, negative 3x squared, 4x, back down here, 2x squared, negative 6x, and 8. And again, here, you're doing the diagonal. So I start with x to the third power, 3 minus 2, or 2 minus 3, negative x squared, negative 6x minus 4 is negative 2x, and then we have plus 8. Okay, so I will let you do whatever method you choose. You can practice with 4 and 5, and then you can email me your answers. Okay, so just like we said before, you're not gonna, chances of them giving you like what I call bare naked problems are slim to none. So this is the kind of problem that you most likely will see, a word problem. So we're gonna find the area of the large rectangle. And then you're gonna find the area of the small rectangle, and then you are going to add them together. Okay, so, and again, you can FOIL, you can distribute, or you can use the box method. It's 100% totally up to you. So 3x minus 4 times 5x plus 12, this is the large. If I wanted to FOIL, I would have, the first terms are 3x and 5x, so it would be 15x squared. Outer terms would be 36x. Inner terms would be negative 20x. Last terms would be negative 48. Combining like terms would be 15x squared minus 16x minus 48. So this is the answer to A. Find the area of the large skyscraper. To find the area of the small, I'll go ahead and do the box method. So 2x minus 3, x minus 8, 2x squared, negative 3x, negative 16x, and 24. Combining like term gives me 2x squared minus 19x plus 24. So that's the answer to B. The answer to C is combining, find the total area, which is combining like terms. So I have 17x squared minus 35x minus 24. Okay, so that's the basics of multiplying. We have some nifty tricks that you don't have to memorize. So if you can just memorize the pattern, you'll be good. So I'm going to go ahead and show you. Whoops. The first one, the second one, okay, let's erase because I made a mistake. x squared plus, I'm trying to do the shortcut in my head and it's not working. Thank you. Sorry. Okay, so this is, oops, sorry, I got sidetracked. 10x plus 25. So this would be 4x squared minus 12x plus 9. So there are rules. The first term, we just square the first term of each. The last term, we squared. The middle term, it's 2 times the first term times the last term. Okay, this is called, and you're going to see on the next slide, this is called perfect square binomials. And the nice thing about this is it is on your formula chart. Okay, so right here we have square of a binomial. This right here is what we just talked about. You don't have to think about it. It's on your formula chart. Same thing when we subtract. And it's on your formula chart. So these are really, really easy. I square the first term. I square the last term. And then I multiply the first and the last term. So x times 9 is 9x. And then I multiply by 2. Same thing here. I square my first term. I square my second term. I multiply the two terms, so negative 7 times x is negative x. And I multiply that by 2, so negative 7 times 2 is negative 14x. And it doesn't matter. You're still going to do the same thing, even if you have a leading coefficient that is not 1. 4x squared is 16x squared. The last term squared is 4. 2 times 4 is 8. Times 2 is 16. Perfect square. Okay, perfect square. And again, this is not something you have to memorize. It is something that is on your formula chart that you can use. Okay? One more, excuse me. Okay, so let's look at this pattern. Okay, when I do, and I'm going to do FOIL because I can do it quick. I have first terms, outer, inner, last, combining like terms, they cancel out. So I have x squared minus 9. First terms, outer, inner, last. Negative 5 plus 5 is 0, so x squared minus 25. So here I have first terms, outer, inner, and last. So 9x squared plus 4. Sorry, not plus 4. This is minus 4. I got ahead of myself. I'm sorry. Okay, so try and come up with a pattern. Okay, basically if I have, if they're the same, and in class we talked about how they're twins, we have special cases. The perfect square, those are twins, identical twins, because it's the same factor. Here, I've got twins, but they're fraternal twins. They're different because one is positive and one is negative. So what you do, you square the first term, square the second term, and it's a difference of two squares, and difference means subtract. Okay? And again, this is also on your formula chart, so this is nothing you need to have memorized. But it's just, and it will go quick. You'll get the habit of these, okay, pretty quickly. So here I have x squared minus 64. M squared minus n squared. Okay, we have twins. They're fraternal because one is adding, one is subtracting. My first term squared minus my last term squared. Okay, and then number 9 is, what is this, a perfect square? Are they identical twins, or are they fraternal? So that's what they're asking there. Is she correct? Okay, so the last part here is being able to identify which is which, okay? So being able to identify what special product is this. So here I have x minus x, which is, or squared, which is the same as this. Okay, so that best matches D. Because it's identical twins, I'm squaring the first term. Negative 8 times negative 8 is 64. Negative 8 times x is negative 8, and I multiply that by 2 to get negative 16. For number 12, this is a difference of two squares because I have the same, I have x plus 6, same numbers, x minus 6, so they're twins, but they're fraternal because one is addition and one is subtracting. So this is a difference of two squares. So I square the first term, square the second term, so that is E. Same thing for number 13. It's a difference of two squares. So I'm going to square the first term, square the second term, and subtract. For number 14, 3x plus 1, this is a perfect square. So it is A. Number 15 is a perfect square. So it is F. So this is what you will be practicing on homework number 8. So the homework that matches this that I will email you when I email you the link to this video will be homework 7, homework 8, one side multiplying, one side talking about the special products, okay? And then what I need you to do is I need you to do the exit tickets. So after you do this, after you watch the video and go through the notes and do the assignment, and then you can do the exit ticket. And I will try and have this all uploaded for you and emailed to you by tomorrow, so that on Friday you can take the quiz with the rest of us, if you can. If not, just get it to me by next week. Okay, so I hope this helps. Let me know if you need anything else.